Are you still with us, John?
Yeah, I sure am.
Do you
Here
want
I
to run?
am.
Do you want to run through your Mars data?
Sure, I would love to.
Okay. Yeah. Let's do that then. Let's do that.
Okay. Let me see if I can get everything pulled up on the screen share. And
Yeah.
so I
Yeah.
can
Go
put the
through
PowerPoint
that.
presentation up. And let's see. Okay. Let's see where share screen. And then
And thank you for your patience, sir.
oh, absolutely. No, we're watching experiments, you know, and I can tell you that one reason I became a theorist primarily is because experiments were so frustrating. But
Yeah.
yeah, let's see. Okay, let me. Okay, I'm trying to find out how to link the okay, files. Okay, here we go. Just here, let me pull up the file. Then we ought to be able to put it on the screen. I'm sorry. I would have prepared earlier if I thought we were going to talk on this. Okay. Oops. Okay, I have the file pulled up in front of me. How do I get it on our screen? Okay, zoom in. Okay, so we want to go from here to I'm sorry, bear with me, folks. I'll be right there. Just trying to get this thing
No, you're fine. Take your time, sir.
oh, okay, yeah, sorry.
Try the yeah. So
Okay, here we go.
okay.
Okay, so what we're doing is we're pulling this up. And the presentation I'm going to show you was what I presented at the Mars Society conference about 2 weeks ago. And it was well received. See, can you see this now?
No, not yet. I think you have to finish your screen share. I bet you started it.
Oh, okay. Pardon
It's going to
me.
make you select the window.
Okay. Oops. Okay, here we go. We'll just put that over here. Okay, finish screen share. Share screen. Okay. Okay, there it is. Okay, I'm screen sharing. Now see your application. Can you see?
Why is it doing that? That's weird. It is, but it's only showing a tiny little bit.
Okay. Here, let me.
You know what? I've seen it do that before. I don't remember why.
Well, let me, as usual, you know, Einstein said insanity is trying to do the same thing several times, expecting a different result. But he didn't deal with computers.
Yeah, John, you may have to. You know what? Do this. Can you share your entire screen? Here, let me stop your screen.
Yeah, let me. Sure, I can believe. Okay, new share.
Yeah, here, stop sharing. Okay.
Okay.
Try sharing the entire screen. which isn't optimal, but
Okay, okay, basic advanced files.
nope, there
Let me
should
access.
be
Oh,
probably
okay,
option number 1 is share your entire screen.
okay, okay. I'm into share screen, and then there should be. I don't see any. Just says basic. Okay, basic portion of screen.
It should have, yeah,
PowerPoint as a virtual background.
no, you should have, if you look down, you should have desktop 1, desktop 2, desktop 3, something like that. Top left,
Oh,
desktop 1.
okay.
In basic, and then desktop 1.
Oh, okay,
I believe.
basic.
Yeah, and then look down right below basic. It should show desktop 1.
Yeah, I can see the presentation on my screen.
Okay, then double click on that. Try double clicking on
Okay.
that. Let's take a look. Nope, that's
Wrong one. It doesn't, okay, I'm screen sharing. Okay, let me try again. Whoops.
that was me. I just stopped it. So okay, if you click screen sharing.
Yes, I'm sorry.
Try click share. No, you're
I
doing
should have
great.
been preparing for this ahead of time.
You're doing
Okay.
great.
Okay, so screen sharing.
Yeah, so try you click share, and then it's going to have at the top, it should show basic advanced to files, which you already mentioned.
Basic. Okay.
Okay, and then in basic, you've got a bunch of different windows there. And
Right.
what's it showing? Does it have one that says desktop?
It doesn't say desktop. It simply just says, it does show a PowerPoint presentation that I'm trying to put up on the screen, but it doesn't show the,
if you look at the different windows, it should only give you a few different options there. What are some of your other options?
well, there's Mozilla Firefox, Mars Society meeting, which is
is that the PowerPoint?
Well, then I have the PowerPoint up and it's lit up in blue. So normally I would just click on that. And are you seeing this now?
It says John Brandenburg has started screen sharing.
Okay.
There we go. We got it.
Okay, very good, very good.
Okay, so try yeah, slideshow. Try that.
Yeah.
It is being a little weird. It's John, you got it. You got it.
All right. There's a very Martian scene from Earth, and of course, the Crab Nebula supernova remnant. This is what I presented at the Mars Society meeting in Phoenix on October 21st. I'm hoping that ends up on YouTube. The whole presentation with me talking and the PowerPoints. But in the meantime, here we go. This introduction, I had noted the boat, the brightest of all time gamma ray burster, which probably sterilized the entire galaxy it was in. We live in a violent universe. The universe is both dangerous and beautiful. So I just wanted to plant that thought into everybody. And of course, this is our planet. You'll notice, by the way, this is a view of Africa and the Sahara and the Namibian desert, the south. They're bright red. They're bright red because of oxidized iron in the Earth's surface. And that's the same thing that makes Mars red. So, and you can see also Arabia, bright red. So that's because of the oxygen in the Earth's atmosphere. So we can actually realize that Mars has a highly oxidized surface. Now, why did it get highly oxidized? I won't speculate right now. Let's just say it is consistent with Mars having a photosynthetic biosphere in the past. But anyway, past and present. Mars, past and present. what destroyed Mars, what took it from a planet that looked like Earth to its present state. We're going to be discussing what's called R process. You can look it up on Wikipedia. It's intense bombardment of heavy elements like uranium, thorium, etc., in the core of a star, of a supernova. When the fusion neutrons hit those things, and you get sometimes the neutrons are absorbed, creating even heavier elements. Sometimes they split the atoms, so that's all under the umbrella of what's called R process, meaning R standing for rapid. Okay, xenon evidence of R process events, krypton evidence of R process events on Mars, and nitrogen and argon isotopes, which is new data. Argon and nitrogen are the second and third most abundant elements, most abundant species in the Martian atmosphere, molecular nitrogen and argon. And so we will find some really fascinating evidence looking at those two, and that's very new. And then we have potassium and thorium. And then we have evidence for this massive R process events. If you look up R process, there are only two known places where you get R process. One is a supernova, in the core of the supernova. The other is in a thermonuclear weapon. So we'll have energy release estimates and summary. Okay, so we know that Mars used to have much heavier atmospheric pressure and warmer temperatures, so it allowed liquid water to flow for long distances and long periods. And this is a classic oxbow lake, apparently preserved on Mars, very common in the Mississippi and Amur River valleys. So Mars, and this means the water flowed for millions of years. Mars' past was much more Earth-like for a long period, billions of years apparently. This is what ancient Mars looked like. It was dominated by an ocean in the north, and in the south was apparently quite dry and free of water erosion. But the north, there's heavy evidence of heavy water erosion throughout its geologic history. So we'll talk about Mars Polar Lander results. Mars Polar Lander landed in the north on the old ocean bed. The water ice found on Mars was found on Mars right under the surface. Of course, we now have we watched formation of a crater on Mars, and what came out was big blocks of ice. So there's plenty of water just below the surface on Mars. So the soil they found could support life, and the soil was consistent with an old ocean bed. It was salty. Old Mars ocean hypothesis is confirmed, and I want you to know I was the first person to propose that at the Mecca conference. I presented a paper called The Paleocean of Mars in 1986 at the Mecca conference, Mars evolution of its climate and atmosphere. I'm kind of the Rodney Dangerfield of Mars because of my involvement in the Cydonia investigations. I don't get any respect. But Wikipedia was honored me by giving me reference number 1 on the Mars ocean hypothesis. But we have Mars that looked very Earth-like, and now its present form. These are the northern plains of Mars. There's a large impact basin, 200 kilometers. It's a double ring structure. It's almost the same size as the Chicxulub impact on Earth. And you can see obviously why I proposed that there was an ocean on the northern plains. You can see the terrain changes dramatically from what's this one common elevation line to the north. But apparently Mars suffered a large impact late in geologic time. You can see that because there's not a lot of craters on this. Of course, all the craters are sparse here. They're very common here, but you can see in this impact basin, there are very few craters. meaning this formed in recent geologic times. And it also looks like it's partly eroded. Whoops. Okay, so they divide the ages of great epochs on Mars into the Noachian. This period right here, heavy water erosion, heavy bombardment, and then there was, whoops, there's the Hesperian. So there's lower Noachian, mid Noachian, and the lower Noachian, and then there's the early Hesperian, late Hesperian, and then at the early Amazonian age, suddenly the rate of water erosion on Mars declined dramatically. And this is apparently the epoch also, the best they can determine, that this big double ring impact happened. However, you can see that water erosion on Mars declined and then it recovered again in the late Amazonian. So there are water channels, old river channels that look like they date from the Amazonian, which is recent geologic time. So Mars suffered catastrophic impacts. It's next to the asteroid belt. It's accident prone, but apparently could recover, just like the Earth recovered from the Chicxulub impact. But something killed Mars. Mars dies at some point. Why did Mars die? There's evidence. Oops. Pardon me, the screen is hyperactive. Thank you. Okay. Evidence of a massive nuclear event, or process events on Mars, apparently 2 of them, 180 million years ago. The evidence is a xenon-129 spike in the atmosphere. Xenon-129 is hyperabundant in the Martian atmosphere compared to Earth or Jupiter or the solar wind or the average of all the meteorites that end up on Earth. Also, the Krypton 80 in rocks formed by an intense neutron bombardment. This has been well known on Mars now for many years. Mars rocks look like they were at one point bombarded heavily by neutrons, creating Krypton 80 from bromine 79. There's other isotopic evidence. And then there's finally the thorium-potassium scars on the Mars surface. These are both solid elements, of course, and they orbited satellites around Mars with gamma ray spectrometers, and they were able to map the gamma ray emissions from Mars. And of course, every radioactive element has a gamma ray signature. They were able to identify thorium and potassium. And those are both very long-lived isotopes, and they form a similar radiation pattern of 2 hotspots on Mars in the north, or where the ocean used to be, and then also an antipodal deposit on the far side of the planet, indicating consistent with shock waves going all the way around the planet from the 2 explosions in the north and finally colliding with themselves on the far side at the antipode and depositing debris. So here is Earth versus Mars xenon. Earth's xenon spectrum, xenon has, roughly 5 different stable isotopes, or these are, in fact, it looks like more like 7 or 8 stable isotopes. These last forever. And so Mars has this very different xenon spectrum from Earth. You notice it looks the same for the heavier elements, the heavier xenon isotopes, but at xenon 129, there's this there's 2.5 times more xenon 129 in proportional to xenon 132, which is the kind of standard stable isotope of xenon. On Earth, the xenon 132 is slightly larger than the 129, and but on Mars it's 2.5 times. Now, when I showed this, I was working at Sandia National Labs in Albuquerque, New Mexico in 1984. And I was standing in line for the Xerox machine. That's what we did in those days. Rather than downloading documents off the net, we would find our articles and books, and then we would Xerox them. And so I was standing in line at the Xerox machine in an unclassified area of the lab. And there was this very genial fellow standing behind me. He wanted to Xerox something. And he noticed I was carrying a book of the Viking, results of the Viking expedition, and where they measured all of the xenon isotopes in the Mars atmosphere of 2 landers. And he said, "Oh, that's interesting. Why are you interested in Mars?" And I showed him the Mars isotopes. I said, "This is really interesting, this big spike at xenon 129. And his smile vanished when he looked at this. He said, "Look, let me look at that." And he looked at it and his smile vanished. And he said, and he looked me straight in the eyes and said, looked up from the book and said, "Someone nuked them." And then he looked embarrassed, like we were in an unclassified area. And I knew that look. It meant he had said something classified related to nuclear weapons in an unclassified area. So he simply said, "I'm sorry, I have to go." And he set down the thing he wanted to Xerox and walked back into the classified area of the lab through this one door that led to the classified area from the library. So I did not figure this out myself. I thought it was odd, but what happened was a nuclear weapons scientist said, this is what nuclear weapons signature, this spike at xenon 129. So I've been working for a long time to basically verify that. It is true that because of open air testing, xenon 129 has become more abundant in the Earth's atmosphere, but I couldn't find any unclassified places where they would talk about the results of nuclear tests doing air samples. So I kept looking and looking and looking. The end of that story is I found that supernova simulations of our process show this dramatically. I'll be showing you that in a minute. Now, there was a meteorite that fell in Old Mexico in 1969. It's one of the most studied meteorites in history. It's called Allende because of the place where most of the fragments fell. It exploded in midair. Hundreds of fragments were recovered. The rock was older than the Earth and contained pre-solar grains that apparently predated the condensation of the solar system. And if you separated those out, they showed this, a big spike at xenon 129, whereas the rest of the xenon spectrum looked fairly conventional, like Earth or Mars. In the heavier isotopes, there was again the spike at xenon 129. Now, what this xenon is supposed to represent is the fact that the solar system itself formed as a result of the shock waves from a nearby supernova. So we had in pre-solar grains the results of supernova explosions. And so this is how the solar system formed. So this is a very tiny fraction of the Allende meteorite, but it is basically you dissolve everything in acid, and this is what's left. And you crush that and release the xenon trapped in it, and it gives you this spike, which looks like Mars, or at least it approximately looks like Mars in this xenon 129 spike. But this is not from Mars at all. This is a completely different rock. Its oxygen isotopes don't match, or anything else matches Mars, but it has this very Martian-looking xenon in one small portion of the mineralogy, the pre-solar grains, they call them. So, pre-solar dust, isotopic evidence in primordial meteorite Allende, which is like 4.6 billion years old, older than the Earth or Mars, showed solar system condensed from supernova products. That's the interpretation. Supernova explosions are characterized by intense irradiation of heavy elements by high energy neutrons produced by fusion. And it's called R process, R for rapid. So if we take that, if we find in the literature that they have done simulations of supernovas, and they get a xenon spectrum from that, those simulations. And what it looks like is that the resulting xenon spectrum, mass spectrum distribution resembles Mars. In fact, it has the xenon 129 spike, just like Mars. So I have labeled R process as the stars with the blue, Earth is diamonds, and Mars is red triangles. And you can see that the place, it gives approximately what we see on Mars. Now, I want you to know there are conventional models of the xenon 129 excess. The model goes that Mars lost its early atmosphere. And then, so all the gases were swept off Mars by early impacts or something. And then iodine trapped in the rocks of Mars decayed, iodine 129, 16 million year half-life, and resulting in outgassing of xenon 129. Forms a thin new atmosphere, which would be enriched in xenon 129. Very good. However, there are other elements that have been would have been in the rocks with like longer half-lives, especially plutonium-244, which is formed in hydrogen bomb explosions, but it's also formed in supernova by our process. And the original, they've found the original rocks from pre-solar grains. Some of them show evidence of this plutonium-244. It has an 80 million year half-life, not that much different in terms of geologic time from the 16 million year half-life of iodine 120. And it puts out a completely different spectrum dominated by xenon 132. And also, of course, you've got uranium and thorium isotopes, and they should also outgas, making xenon 129 versus the abundance of xenon 132 close to 1, like on Earth. And not only Earth, but Jupiter, the average of meteorites, and the solar wind from the sun. So you get a completely different spectrum from slow fission by moderated neutrons. Like here's two graphs. One shows the slow neutron fission, U235, and it produces a xenon spectrum that is peaked at like 132 or 134. And plutonium-244 decay is shown here, and it has a peak at 132. So we probably get a lot of our xenon 132 from the decay of this long-lived plutonium isotope, relatively long-lived compared to the plutonium we use in weapons and things like that. And it's got an 80 million year lifetime. So it would have outgassed later and made the xenon atmosphere, xenon 129 excess atmosphere, look more normal. But they see no signs of that. They commented that there seems to be no, they have to say, well, it's like the outgassing of the xenon from plutonium-244, somehow that was repressed, but the xenon from 129 from the iodine was liberated. And that doesn't, that's strange because Mars just is outgassed its entire history. It's got big volcanoes, all of this stuff was being dumped from the interior of Mars to the rocks into the atmosphere. So this lost its early atmosphere, and it was replaced by the decay of xenon 129. Fails because it fails to account for the fact that a bunch of other isotopes would have decayed and contributed a bunch of xenon 132, making the two things roughly equal, like they are on Earth or Jupiter or in the asteroid belt or in the solar wind. So that fails. As it turns out, since they can date the approximately the formation times, crystallization times of the rocks from the Mars meteorites, they can actually, and look at the trapped gases in them, if they plot them on a map of 136, which is one of the heavier isotopes formed by plutonium and thorium fission, then you get you find out that a large fission contribution is present in the Martian atmosphere. And then there's also this xenon 129. So the present Mars atmosphere began with very primitive atmosphere that had very little xenon 136 and very little xenon 129, and then somehow evolved with some large amount of fission to its present state. Ancient Mars showed that no 129 excess was present in the early Mars rocks. The xenon 129 excess appeared in recent geologic time on Mars. Now, if you look at S process, which is like an ordinary star cooking stuff in its core to make heavy elements by neutron absorption, kind of a incremental process, building up atomic number, then you get very little xenon 129. And this is also what it looks like from a moderated reactor, nuclear reactor with moderated neutrons, which is, so the neutrons are slow. They hardly create any xenon 129. They mostly create xenon 132, as it turns out. So, which isn't shown on this graph because it's used to normalize everything. So xenon 132 abundance from these simulations is 1. So that's slow process, not what happened on Mars, apparently. What happened on Mars was our process. The signature of that is a big spike at xenon 129. It's the signature of our process, which is, of course, found in supernovas cores and also a hydrogen bomb explosion. They use the same physics. So I've now found in the literature where the xenon 129 is connected to nuclear weapons processes in the open literature. I've shown, by the way, these results to many nuclear weapons experts, and they all say, yes, the xenon 129 is signature of a hydrogen bomb explosion. So, but now I found in the open literature from supernova simulations that's what, and here's so anyway, so in fact, they're showing 2 different studies. They varied some parameters a little bit, and the xenon 129 spike stays, but the other things change a little bit. But so with their assumptions, so in particular, what changes a little bit is the 136, which is due to fission of uranium and thorium so the xenon 129 spike stays pretty much the same, but what does appear in some studies is a modest amount of xenon 136, a heavy isotope of xenon. So the mystery is now solved. I found in the open literature, yes, hydrogen bomb processes cause the signature of them is this xenon 129. So what you can say is the only 2 known phenomena that could have occurred on Mars, 2 known phenomena. One was a supernova. We know that didn't happen on Mars because there wouldn't be a Mars. There wouldn't be a solar system if that had happened. It was supernova. But the other possibility is that is known, the other known process is a thermonuclear weapon. In this case, of massive size. There's only 2 known R process events. There may be another one in nature. I mean, we found natural nuclear reactors. There may be, nature can be pretty creative sometimes. I'm not discounting the possibility this could have been somehow natural, like a supernova. But right now, the only thing we know that has that kind of physics, R process physics, other than a supernova, is a human-created thermonuclear explosion. Now, another product of our process is Mars krypton, is the krypton. When you create a R process explosion, it's an explosion, of course, like a supernova or a miniature supernova. It showers everything with neutrons. If you shower rocks with neutrons, you turn the bromine 79 into krypton 80, which bromine is chemically locked into the rock, but once it turns into krypton, krypton is inert, it becomes a gas, and it slowly diffuses out of the rock and goes into the atmosphere. The rocks they have from Mars showing this krypton 80 retained inside them, and also in the Martian atmosphere, there's a lot of krypton 80. It requires they had to put rocks in nuclear reactors and irradiate them to get the same effect. Neutron fluence of 10 to the 15th neutrons per centimeter squared was required on equivalent Mars rocks to produce this effect that they have found. So something not only created a whole bunch of xenon-129, it irradiated the surface of Mars with an enormous blast of neutrons. If you look at the rest of the Mars krypton isotopes, they resemble the sun, which is, of course, a nuclear furnace. They're much different from Earth, and they're dominated by light krypton. Normally, if you have fractionation in a planetary atmosphere, the atmosphere is being blown off by part of the solar wind, like it doesn't have a magnetic field, and it's losing atmosphere to space, then the lighter stuff floats to the top of the atmosphere and gets scraped off, leaves heavier stuff. That's but we don't see that on Mars. We see dominated by light elements caused by fission-associated processes, and that means that it was a nuclear process on Mars, not fractionation by the solar wind, scraping off the top of the atmosphere. If you look at Mars krypton versus krypton 84, which is a standard kind of the most abundant part of the neutrons of the krypton spectrum, you find there's big peaks at krypton 80. Some of the Mars krypton looks just like the solar wind. Some of it is highly enhanced with krypton 80. These are extractions from Mars meteorites. And also we can compare it with the Earth's atmosphere in the blue. We can see that that is dominated by krypton 80 and krypton 86. So any case, the krypton, if you compare the krypton and the xenon-129 relative to xenon-132, which is kind of your standard, your reference for xenon, we find that the most primitive meteorites, one of this is called Chisigny. It's an older meteorite, and it's full of olivine, a green rock found on Earth, but it's unstable to water exposure. So this thing stayed very dry during its history. And So basically, we find that Chisigny is considered the kind of standard of what the early atmosphere of Mars must have looked like. It was low in 129 and low in Krypton 84 relative to 132. But then if you look at the younger meteorites, they show more and more contribution from 129 and Krypton 84 to the present Mars atmosphere. MA is extracted from what are called the Shergottites. And then, of course, there's the Mars atmosphere from measurement from Viking. So it looks like Mars gained a bunch of Krypton and a bunch of Xenon 129 in recent geologic times. It's found in the young meteorites, but not the old meteorites. Now, there are other isotopes that indicate intense neutron bombardment of the Martian environment. And this is new data, by the way. The first most abundant gas in the Mars atmosphere is carbon dioxide. The second most abundant is molecular nitrogen, rather chemically reactive, especially if there's a lot of very hard UV because there's no ozone layer. The nitrogens get broken up and they tend to react with things. And then there's also the third most abundant gas is argon. And it has several stable isotopes, 36, 38, and 40. 40 is hyperabundant on Mars. The other, and argon 40 is caused by neutron bombardment of rocks with potassium. So Mars apparently suffered it's got 6 times more argon 40 in proportion to argon 36, the kind of standard, than is found on Earth. Now, also, the nitrogen is the nitrogen in nature is dominated by nitrogen 14. There's a trace amount of nitrogen 15, but on Mars, there's twice as much nitrogen 15 as there is nitrogen in proportion to nitrogen 14 as there is on Earth. And if you study, if you look up the book by Gladstone and I think it's Dolan, Effects of Nuclear Weapons, it can be found on the web. One of the effects of a nuclear weapon going off in an atmosphere, in the atmosphere, is the neutrons run into a bunch of atoms and thermalize, they slow down. And then they combine with the nitrogen 14 in the Earth's atmosphere, forming nitrogen 15, and they emit, the reason it's important is they emit a ferocious gamma ray, very high energy gamma ray, so that if there's a nuclear attack on a city, the neutrons make the atmosphere itself a source of deadly radiation by the neutron bombardment of the nitrogen in the air, causes gamma rays to come down and kill everybody because of the neutron interaction with the nitrogen 14. And that leaves behind nitrogen 15, which is stable. But on Mars, there's twice as much nitrogen 15 in proportion to nitrogen 14 as there is on Earth. So both the argon 40 data and the nitrogen data, the two most abundant gases in Mars atmosphere after carbon dioxide, both show evidence of intense neutron bombardment of the Mars environment at some point. Now, when did this, and here's, of course, the thermal cross sections for thermalized neutrons. It's got a big nitrogen 14 has a big absorption cross section, and to go to nitrogen 15, oxygen and carbon, by the way, are pretty much unaffected by this neutron bombardment. That's why they use them in reactor moderators, because they just don't absorb any neutrons, or at least very few. but nitrogen soaks up neutrons to form nitrogen-15 and gamma rays. And also potassium has a big cross-section. Barnes was a joke. It meant his cross-section as big as a barn door. Absorbs. The first step is that potassium-39 absorbs a neutron, becomes potassium-40, which is radioactive, but it has like a billion-year half-life. And then if the neutron bombardment continues for like a few seconds, then you get another neutron gets absorbed by the potassium-40, which has an enormous, it's 35 times larger cross-section for absorption than even the potassium-39, and it then turns into argon-40, which then gases out. So this results in a much larger argon-40 versus argon-36 ratio of abundance if there was a neutron bombardment of the Mars surface. And the nitrogen-15 and 14 ratio being larger on Mars means the atmosphere of Mars suffered a huge neutron bombardment, just like and consistent with the results from the Krypton 80. Now, the timing of this event can be tentatively assigned to because there's a lava rock, ETA 7901. In fact, it was the first meteorite that was actually recognized as being Martian, and it's a lava sandwich. It was two lava flows that flowed. One flowed and then not really even barely cooled off, and then another flow flowed on top of it. So the whole thing became one rock, but with two distinct mineralogically distinct areas of lava in it and a contact line. And one part of this lithology shows a lot of neutron exposure, and the other much less, or maybe even nothing in some cases. What that means is there was an intense neutron event during the time when this rock was being formed. It was forming from molten lava, a molten lava sandwich. And during the time the lavas were cooling off relatively, they were irradiated. So one retained a lot of radiation damage, the other one was still molten and didn't see it. So it's so this meteorite is tentatively, they're fairly confident of the date of 180 million years old. That's basically the boundary between the Triassic age of dinosaurs, the earliest age of dinosaurs, and the Jurassic. The early dinosaurs all walked on all fours. In the Jurassic, they started walking on, some of them started walking on two legs, and you got the first mammals, and you got the Stegosaurus, Allosaurus, which is a miniature Tyrannosaurus Rex, and then you got the Brontosaurus in the Jurassic. So the dinosaurs really went to town in the Jurassic, and then later they were, the later period was sort of Cretaceous, where you had the Tyrannosaurus Rex and Triceratops and some of the other dinosaurs. But anyway, the strongly differing neutron bombardment, evidence of neutron bombardment, strongly different intensities on different parts of this rock, which have the same geologic age. I mean, there was within the two lava flows formed within the margin of the air bars of each other. So they're geologically, they're basically the same age, but they show different exposures to neutrons. Apparently dates the event on Mars to 180 million years ago. That's a long time before there were any people. Now, there's a way to test this R process hypothesis, and that's to go to Mars, or in the Mars, some of the Mars rocks that we've gotten, look for plutonium-244, which has an 80 million year half-life, and it's formed in R process explosions. So once you find plutonium-244, then this confirms this. And so that's what you look for when you go to Mars, to confirm this. Now, gamma ray maps of the Martian surface taken from orbit, because the Mars atmosphere is so thin, the gamma rays go right through it, shows two hotspots on Mars. And then if you average the place of the two hotspots, it gives you an antipode on the far side of the planet where the shock waves wrapped around the planet and then collided with each other, depositing a bunch of radioactive debris, and it's called the antipode. And I'm deeply grateful to Ed McCulloch, I believe he's at Lockheed Martin now, for pointing this out to me. And so that's in potassium. Potassium has a very long memory for neutron exposure. It has like a 2 billion year half-life to turn into, it slowly decays into argon-40, but it takes 2 billion years roughly for the half-life of radioactive potassium-40. So it has a very long memory of something happening on Mars. Something that happened 180 million years ago, that's nothing to the potassium. Same goes for thorium, which is another radioactive element. You'll notice the thorium and the potassium hotspots overlie each other, especially and also at the antipode. Now, thorium and potassium do occur together in nature. They're both alkali kind of metals, but you find big thorium deposits some places where there's not a lot of potassium. So basically, the fact that you've got two hotspots that overlie each other, and then the antipode, it looks instead like these were sites of intense neutron radiation of the surface, carrying a shock wave around, which deposited material that was also radiating neutrons, delayed neutrons from like a big fission event. When a hydrogen bomb goes off, some of the uranium waits a couple seconds to fission and then releases neutrons. So you get a delayed neutron result that would be accounted for by that, by things wrapping around the planet and then depositing debris at the antipode. Now, thorium, which by the way was included in the Canakin nuclear test, was the anti-missile warhead they tested up in Alaska on Amchatka. I believe it was the Amchatka test, about 10 megatons, biggest nuclear test we'd ever done, and we did it in Alaska right on an earthquake fault line. I wasn't there. I didn't do it. So anyway, but thorium, which is also part of the constituent of hydrogen bombs. Your standard hydrogen bomb, by the way, is actually a triple action. It starts with an atomic bomb driven by plutonium generally, creates a nuclear explosion, and they have this big watermelon shaped cavity, ellipsoidal watermelon shape, and they have the nuclear atomic bomb sets off at one focal point. And then there's another focal point, and they put the lithium and hydrogen isotopes in a sphere there, and the atomic bomb generates enough radiation pressure to actually collapse the ball of hydrogen isotopes, and that creates the fission or fusion. So you start out with fission as the trigger, fusion as sort of the detonator cap, then the fusion occurs, it releases 14 MeV neutrons, very powerful neutrons. Those go out and hit the casing, the watermelon casing, which they make out of uranium and thorium. Because even though they won't split for normal thermal neutrons, they will split for 14 MeV neutrons from fusion. That's the R process. So the thorium ended up having deposits that overlie the radioactive potassium. Thorium is naturally radioactive, and it has a half-life of a couple billion years. So it also has a long memory. So we find these deposits indicating apparently large R process explosion here and here, shock waves wrapping around the planet, depositing debris at the antipode. And that's reflected also in the potassium high neutron irradiation of the surface here and here due to these two R process explosions. And again, antipode. So now here's the intriguing thing. The Martian surface apparently is covered with a thin layer of radioactive and radioactive potassium and thorium. But if you look at the Mars rocks, the Mars meteorite rocks, and by the way, when you're looking at gamma rays from the orbit, you're only seeing the top centimeter of the Martian soil. If in order to eject rocks from Mars, they have to come in the simulations they've done from like a meter down or a couple meters down in the Martian surface. Big rock hits Mars, blows little rocks all the way out into space. They circulate around the sun, they end up on Earth. That's the Mars meteorites. But the Mars base rock has much less potassium in it and thorium in it than is apparent from the gamma ray measurements on the surface. So Mars is covered with a surface layer, a thin surface layer of radioactive elements, which is not in the rocks that are below it. That's what you learn from this. Also, I asked the person, I said, gee, the Russians measured uranium on the Martian surface. They couldn't do nice maps like the Americans could, but they found just regular standard abundances of uranium and thorium on the Martian surface. And I said, why don't we see any maps of uranium? And the guy said, oh, uranium was too complicated to measure. And he just walked away from me. And I said, you mean you can't do, I called after him, you can't do what the Russians did in 1973? And he wouldn't answer me. He just walked away. So they apparently have uranium maps, and guess what I think they look like? They look like this. So here's what happened. Apparently, big R process event in Mare Acidalium, smaller one over Utopia Planum. The winds, Coriolis winds meant everything down here, downwind, would have higher shock waves and more fallout. And of course, the antipodes are way over here, and here would show up here. So if you want to know where Cydonia Mensa is, it's right here. And if you want to know where another site of archaeology, where there's another face that looks a lot like the face in Cydonia, it's a face and a helmet, that's found here. So why, anyway, and there would have been an ocean here. So this thing's went off in midair. There are no craters at either site. No massive craters like this. You would have expected to find craters like this happened. No, there's nothing there. It's nice and smooth. So then you say, okay, it was an airburst like Tunguska. This happens all the time. Meteorites come into the Earth's atmosphere. They're not big enough to survive the trip to the surface. They end up blowing up in midair. This object in Siberia in 1908, the Tunguska event, was either a comet or some kind of loosely put together meteorite. It burst in midair. The energy yield was about 10 to the 15th joules. That's roughly a megaton of energy. Okay, so then you do estimates of Mars energy release of the fission, based on the xenon 129. Every xenon 129 represents about 30 fissions, because only about 3% of the fissions produce xenon 129, even from fast neutrons. Based on the irradiation of the rock, 10 to the 15th per square centimeter, you get another energy yield if you integrate that over the Martian surface. You get about 10 to the 25th, 10 to the 26th joules. This is a billion megatons, or 10 billion megatons. The Chicxulub impact that wiped out the dinosaurs on Earth was only 10 to the 23rd. So these R process events were globally catastrophic. They would have completely destroyed any Earth-like planet biosphere, stripped off its atmosphere, and turned the planet from being Earth-like to what it is now. This was far more severe than even the Chicxulub impact, which the Earth recovered from. Remember, Earth is twice as big, twice the radius, 4 times the surface area of Mars, and it survived. The biosphere survived and recovered from the Chicxulub impact, producing us, by the way. But on Mars, the energy was 10 to 100 times larger. This would have been just globally catastrophic and blown off most of the atmosphere of Mars into space. Okay, in summary, Mars climate may have changed catastrophically from Earth-like in recent geologic time. A lot of the water channels they see on Mars don't have many craters in them. That means they formed in recent geologic time. The ocean bed is on the youngest part of Mars, not the old part. Evidence points to 2 massive R process events approximately 180 million years ago. And the signature of that is the xenon 129 and also the neutron irradiation that apparently Mars surface suffered in its atmosphere. The R process events were Tunguska-like airbursts, but far larger. Now, just for a little historic perspective, Hiroshima and Nagasaki did not produce big craters. No, they set off the weapons several thousand feet above the surface using radar proximity. And the reason was to make stronger shock waves that would kill more people. I'm sorry, it was the end of a long and very bitter war. And that's the way they were thinking at the time. And they wanted to shock they wanted to minimize fallout also, but they wanted also to shock the Japanese government into suing for peace. So the origin of the R process events is unknown. I have my own speculations. It looks like, why would somebody drop hydrogen bombs as big as the Empire State Building on an Earth-like planet? Well, I don't think they did it for fun or laughs. I think they were targeting somebody they didn't like. The bombs were so large, would have had, if they were nuclear weapons, and the Russians showed in the Tsar Bomba, by the way, which was only 50 megatons, that they could build hydrogen bombs as big as you could imagine. They basically proved you could scale nuclear weapons to as big as the Empire State Building and they would work. So basically, the origin of these R process events is unknown. The reason it occurred is unknown. How exactly it happened, it could still turn out to be some weird, freaky natural process. I don't know, but it doesn't look like it. It's more consistent with somebody else coming from space, dropping enormous nuclear weapons on Mars in the past and changing Mars from being Earth-like to what it is now. And the question is, why would somebody do that? it makes no sense that if you have a hydrogen bomb as big as the Empire State Building, you launch it into space just so it would do an air burst. No, you end up, that's something you drop from outer space if you're in space already. So the way to test this is to look for plutonium-244 in the Martian soil. There are other telltale isotopes, which are probably better known to the nuclear weapons community, that can be looked for. And so my own belief, we have to go, this makes going to Mars and occupying it and investigating this mandatory, not optional. We must go to Mars, find out what happened. And this requires boots on the ground. You could drive rovers around Mars sites for years and not see what is buried 2 meters under the ground. You need people with shovels and trained eyes to find out what happened there, and maybe even why it happened. So thank you very much. As I said, I presented this at the Mars Society meeting. The audience was heavily dominated by what looked like a bunch of senior college professors, Mars experts all, and the reaction was quite positive. Nobody stood up or, nobody said, oh, you've forgotten this or that. No, they felt I'd covered everything pretty well. It's a mystery, and it's a mystery connected with what looks like a nightmarish tragedy. So we must go up to Mars, find out what happened. And that is the big motivation for you guys to develop advanced propulsion. So go to it. The plan, as they say in Total Recall, Arnie Schwarzenegger has a clip on YouTube you can look up. It says, the plan, get your ass to Mars. Very good. To Mars and then the stars. Thank you very much. Bye-bye.
John,
I'm sorry. I'm sorry. I just one last thing. Okay, if verified, the ISS consortium, which by the way includes the Russians, ought to go up to Mars quickly. Build probes and boots on the ground, discover what happened there to ensure it doesn't happen here. As a hedge against misfortune, Mars should become a permanent human settlement. And I just want to just mention one last thing. In 1971, the Mariner 9 saw a global dust storm, covered all of Mars for like 6 months. People couldn't figure, it was a great mystery to people how you could get a weather pattern like that. And then they discovered in early 1983 that this could happen in the case of a nuclear war on Earth. The discovery of the nuclear winter was because of a dust storm on Mars. This probably prevented a nuclear war occurring during the Able Archer crisis of late 1983. And you've never gone through a international nuclear crisis. This one was classified. You can look it up on Wikipedia. It's all been declassified now, but at the time it was secret. But we could feel it at Sandia National Labs, and you've never gone through a international nuclear crisis until you've gone through one at a nuclear weapons lab. I'll tell you, it's no fun. So anyway, I also write science fiction under the pen name Victor Norgard. And so I wrote this novel, The War of the Singularity, the human race is canceled, where a Mars colony saves humanity. Anyway.
Okay. John, thank you, sir. So let me do this.
Thank you for the opportunity to present.
Let me stop your sharing. And before anything else, with no further ado, everybody, big hand for John.
Nice, John.
He's the man.
Thank you. Thank you.
Thank you, sir. Thank you.
And
thank
Jared,
you, thank you.
you got to let Jared talk. Jared wanted to ask a question.
Yeah.
And we had Jack
Jared's
talk.
still here 3 hours later. Poor Jared.
Yeah, I know. Find Jared and get him back on the
Jared's not here anymore.
I had a
Oh,
quick
no.
question, if it's all right for John, just really quickly. So
Sure.
I'm kind of interested in this idea of quantum entanglement and astro quantum entanglement. Do you think that there's anything to this idea, especially when we talk about nuclear, that Mars and Venus and Earth are all kind of this holographic, they're all connected in this?
I think there's a science fiction movie called Rocket Ship XM1. And I think
Oh,
one
yeah.
of the best sensors of quantum entanglement is the human brain. I think it runs probably on quantum entanglement. And
You know,
that's what, yes.
There you go.
yeah, let me jump in real quick. Jack, did you want to speak in about, did you want to talk at like maybe 5 tonight? Did you have anything that you wanted to present or share or anything like that? Because we got about 10
Jack,
minutes
you're
left.
muted right now. Still, you got to unmute, Jack.
Jack's
Yeah,
got
no,
his
that's fine. That
PhD
was-
hat on.
Yeah.
Let me say the thing about John's talk. You know what? I think that nuclear bomb may have come from the future.
Right.
Could be.
Oh, seriously.
Seriously.
I'm quite serious. It could have been one of ours. You know, because my whole point is that the UFOs, the Tic Tacs, they're time travel machines. Once you can, I got to take this very seriously now. I'm not
Sure.
just. Once you control gravity with small amounts of energy, that's time travel. And I've shown now in some detail
Yes.
how that'll work. And by the way, I'm not the only one talking about that. Is it Michael Masters, Tim?
Yeah,
Michael.
yeah.
Yeah.
And he had a biological focus, but yeah. he
There was
the
a
same
great
kind of idea.
Japanese scientist talking about this with Aspergillus orzae, the miso soup enzyme, the idea that the nuclear bomb created it retroactively. And he has an entire math on ring ripples of time. If something happens and it affects the future, then you can also check and see how it would affect the past.
Well, yes, okay, but I'm talking about actual ships, material ships, traveling in time. And I think these most of the flying sources that we're seeing in the in close encounters of the Navy and with the nuclear bases, they're time travel machines. They're coming from the future. They're not coming from the past. They're coming from our future. And
Right on.
Okay, if they drop bombs on Mars, where's the law of karma? They got them.
Well, I don't know
think-
what led to it. That you could write a science fiction story. What might have done that?
Yeah, all right.
But it could have been some kind of war between the Russians and the Americans. These time chips. Well, let me ask you.
The Jedis.
Yeah. Let me ask you something. This is serious for Elon Musk. You say there's a thin radioactive powder over the surface of Mars.
Yes.
Oh, is it dangerous biologically?
No, it's not dangerous. It's
Okay. All right.
it's they had very sensitive detectors, so they picked it up, but it wouldn't be a hazard. The cosmic ray exposure on the surface, if you're walking around in a Mars spacesuit, would be far more hazardous.
Well, the reason I was asking about Jack was at 5, then we should probably go to Bernie. Then I think that's.
And what?
Oh, well, Jack, if you had a presentation at 5, I would go to you, but otherwise I'll go to Bernie.
No.
at 5.
I'm gonna fade out pretty soon.
Okay. Well, so yeah, in about 10 minutes. I didn't mean to interrupt. So let me go back to questions. We've got about 10 minutes left, and then I'll go.
Yeah,
to
Mike,
Bernie after that.
what's Mike want to say? Michael Boyd.
Mr. Boyd.
Oh, you muted yourself, Michael. You muted yourself.
Unmute yourself.
This time of day, we all get a little punchy. I think that's the problem.
Absolutely. Here. Let me put on my less threatening
I'm
hat.
literally pouring a coffee right now to get ready for my presentation. So
John, that hat looks incredibly threatening. I'm terrified. You know what?
Well-
you want to see my conquest? I'll make this real quick.
Sure.
$50 from Adidas, and they have foam. It's brand new. This is the first comfortable
Ooh.
pair of shoes I've had in 4 years.
Well, Adidas is the way to live your life. That's the only way to do it.
I've been
What-
trying to
what-
keep
what
up
is-
with. I've been trying to keep
Still
up with my.
say,
Okay.
Okay,
Mike,
sorry.
let's speak your piece.
Shout out to the mystery spot on the wall there behind Michael. Just wanted to say, good place to be.
Let's see here if it's gonna work. Can you guys see that?
It says screen sharing
you're-
started.
You have to.
Yeah.
You have to double click. I think, Michael.
Yeah, you have to approve something.
Okay.
You're halfway there. You gotta confirm something or other. There we go.
Okay, yeah, Mike. Yeah, I wanted to address this earlier.
Yeah,
did.
so what I have here is new supercomputer simulation that sheds light on the moon's origin. And basically they're saying a Mars-shaped object hit the Earth.
That is the what do you call that? The Theia theory.
Oh, wait, sorry, we're getting
No,
back.
it's a fairly standard theory now that the Earth formed by a collision of a Mars-sized body in the early
4.5 billion years ago. They say Theia is the name of the object that they think was about Mars sized.
Yeah, I know what you're talking about. And that's when the moon was ejected. That's
So
when
it's
the
a
moon was-
quarrel between two feminine entities, then Terra
Right,
and
and-
Thea.
And the Soviets say that this turned the moon inside out. That's why it's got so much of outer core on the inside, etc.
Interesting. That's a fairly standard theory. I don't think that
Is someone's
The
music
object that
playing?
they
Let's turn off that
collided-
music.
the object that collided with the Earth, in my opinion, is now part of Thea.
It's John's music, I think.
John, you want to mute that music? I don't even know if it's royalty free. They're gonna get us in trouble.
No, that's not my music. I don't
Oh,
think.
it's Michael's. It's Michael's. Okay, here, I'll mute.
Michael.
There we go. There we go.
There we go, Mike.
It's his meditation music.
Mike, turn off that meditation music. They're gonna charge us money. It's
Yeah,
gonna.
now that by the way, it's really interesting that the hot spots of the magnetic field are, in the south. That's apparently a remnant of when Mars had a liquid core and a big magnetic field.
Right.
So it used to have used to have a nice Earth-like magnetosphere, and then
Can you see
apparently
this?
Mars
Mars crust.
Yeah, I hear you. I see you.
Okay, so
yeah. So Mars
my
crust is
question was, so my background's not just in IR, but in magnetics, specifically on your hard drive. They have these little magnetic domains that show up, and this looks just like those magnetic domains on your hard drive. So my question to John is,
Sure.
how did that? Why is that anomaly in the magnetic crustal in the Mars crustal magnetism there? And where you were talking about nuclear events, they were in
I didn't do it.
the hemisphere, not in
Wait,
the southern hemisphere.
Does that mean they nuked your hard drive?
No,
Well, it
I-
looks like
what-
maybe Mars
I was
is a big hard
suggesting-
drive.
That's what I'm
no,
thinking.
what I was suggesting is that's a remnant from when the Mars, after each time Mars went through Earth, it created those effects in the southern hemisphere. And if you look at that
Right.
other video again, you'll see that when it left, there was like there was a piece of it that got pulled down, right, out of the object that hit the Earth. So would that? So my question to John was that a possibility that Mars and Earth collided at some time in the past?
Well, the present orbits don't intersect at all. So I
The
think
story is supposed to be that Theia, the planet, intersects with proto Earth, whatever we're calling that. And then
Right.
when they go through, it goes in and through it. Part of proto Earth and part of Theia come out, becoming Theia. I'm sorry, the moon.
right.
Selene, I think is the moon's name. And then Theia and Earth, they become the new whatever now is Earth. So that is also similar to the Anunnaki kind of tradition in just enough of a nutshell. But this is NASA. NASA says this is what caused the creation of the Earth and why the moon is so much larger, disproportionately large. We shouldn't have such a large moon, especially this close.
And
Right.
also the other thing is they know that there was a proto Earth because the crust is something that came from outside, and they can tell that by the helium isotopes that are in the
Right.
I'll tell you that
are more abundant than they should be.
There's
The
also the
oxygen-
iridium. Oh, good.
I was just going to mention the oxygen isotopes, which is a very abundant element in all of Earth's crust and also the moon's crust. The oxygen isotopes are almost identical between Earth and the moon. So
Mhm.
it looks like the Earth and the moon were born from the same pot of stuff.
And the question is,
God
did
breathed
Mars
stardust, but
too?
what's also interesting about the idea of the Schumann resonance connection here, because John C. Lilly talked a lot of, Michael, you're talking about the almost tree rings from radio affecting growth, right? Because crystal molecules are then having react like covalent bonds, sp2 orbitals are being caused, and it's changing the growth. And so you can actually measure when this happened. This is discovered in mother of pearl in the ocean has examples of this as well. And the big element that everyone seems to forget about is iridium, right? Because iridium, there's one layer of it. It's either from a volcano that brought it from the beneath, or it came from above. And this iridium level seems to be associated with the same period that we refer to as 65 million years ago, whatever that the Jurassic period ending is supposed to be considered. And we have different numbers for that time, but we can see a huge change, not just in environment and an entire shift of all life on Earth, but also this iridium layer, which is, no one seems to push apart.
Good point. Like, right?
Oh, yeah, and you know what? It's 4:59. On that note, now that we have, it's Bernie's turn. Bernie, hold on. Let me do this. Let's everybody give
another 5 minutes. My coffee is still.
Yeah, I think I interrupted Michael. I should be
Oh,
I should be chastised, and Michael, you should be continuing.
Oh, it's okay.
That's right.
No, but 5 minutes until I'm ready. I gotta get this coffee in because it's been a long day before
That's
I.
fair.
Right.
Okay.
So that iridium layer, my understanding, that was a part of that was a result of the
Chicxulub.
meteor that hit off of the Yucatan Peninsula.
Right.
No, that's because of the dating. They can date it by stratigraphy, it's called. Basically, there's different layers, and they can map out the layers and tell by the depth of the approximate time period that it occurred.
The question is whether or not that was a meteor or just a giant eruption from part of a closed off Western hemispheric Krakatoa. That's the other thing.
Yeah, but iridium isn't that abundant naturally, I wouldn't think.
Not at all. That's the big beauty of it. Either it was the only supply or it came from somewhere else.
Yeah, well, like I said, the outer crust of the Earth is all extraterrestrial. It all came from space. It's only the inner core that remains, and there's a distinct transition zone between the old and the new.
Well, you have a good point. I think doesn't the Earth pick up like I don't remember what it is, 1 billion tons of dust from space every year too? We don't even think about that. Most of that goes in the ocean, right? But yeah, if you look it up, I've seen calculations on it, how much space dust we just pick up, right? Just crap floating out there that we fly through.
Well, I would think Mars would get more space dust because they're closer to the meteor belt, so the asteroid belt, right?
So the most that we get is at the north and the south, right? So the South Pole, like Antarctica, is where you want to go if you want to pick up meteors, because they get the least shredded up and the least pushed to that point. But it's a lot harder, and there's some areas. Apparently, Chile is really good. It has been linked to the ozone layer, like a thinner ozone layer over Chile. But the main thing that's stopping it is the Van Allen belt has this man-made nuclear belt, because we've put so much nukes into the atmosphere. Operation Argus, et cetera. Yeah. And it's now there. And so it's shredding up stuff, which is, they put it in the newspapers or NASA and Spectrum, IEEE put in Spectrum. They're like, oh, man-made nuclear belt is great. It's protecting us because it's shredding stuff up as it goes in. It's like, you see how the Azabos below?
This is like people saying, oh, it's good we're doing global warming because otherwise we'd be in an ice age.
Yeah, wait a minute. That means that space junk belt that we have is protecting us from stuff.
Absolutely. It intercepts a bunch of the meteorites.
They're doing us a favor, Tim. It's all part of a...
That vein, I want you to think all of this dust coming down from space over the billions of years would have borne a big dust layer. human being comes from the word humus, which means dust. So we're actually all extraterrestrial.
Well, that is very Catholic of you, Jesuit. We are dust God breathed, I guess stardust.
Absolutely. And the dust came from outer space. So we're all extraterrestrials.
That was a little more Pere Chardin,
Yeah.
but that's still good.
I'm not depressed enough to be Catholic. Not with my new shoes. With my new shoes, I'm happy. I've been doing
just an
Converse All-Stars for
Episcopalian,
4 years.
Adidas will change your life. Did you see that thing where they found frozen shoes in Scandinavia from the Ice Age and they look identical to Adidas? They even have the straps of the leather in the same way. When you get it right, you don't change it. That's all there is to it.
That's right. No, I've been doing All-Stars. It's like walking on concrete, right? But that's because I have a daughter, and
that does seem kind of Catholic. That seems very masochistic. You should.
It does. Yes, Converse All-Stars, invented in 1920 and not changed since. So, yeah,
you're doing penance.
It is. It's like penance. It's like you walk in them and your feet just are in pain after but you know what? They're really stylish. That's what all the kids are wearing these days. But then I just realized.
I hate to bring up how crazy this is, but the shoes I wear a lot of the time until winter comes are these Gettas. But I swear this makes sense. I wear these in the mud. And so if you're outside in the mud, you're literally stepping in, it goes into the mud and you're a foot above the mud all the time. And it's like stepping on hardwood floors. So
there you go.
But yeah, I would say Adidas are the way to go for sure.
Yeah. If those had comfort foam, you'd be set, man. So
yeah. Dude, those super clouds. Have you seen the super clouds? The superstar clouds from Adidas are the way to go. Those are the best floppies.
Okay. Now that we've done free advertising for 4 shoe companies.
Oh man, that's too bad because there was the segue to Vectran. That the way that they make the inflatable spaceship is that they use Vectran, but in order to make Vectran affordable, Nike released Lunar Gear, and Lunar Gear shoes are made out of Vectran, so they could make millions and millions of dollars up front off selling these shoes, and then now they can build the space stations that expand out of Vectran.
Very good.
Did you guys ever hear of Blind Frog Ranch in Utah?
No, is that a shoe brand?
No, Blind Frog Ranch. It's like Skinwalker Ranch, but
oh yes, Kai in chat said yes.
It sounds like it's a lower rent district than Skinwalker.
Skinwalker.
I don't know. It seems scary. Blind Frog Ranch.
I found all these meteors.
Oh,
so
well,
a meteor crash site there.
So you're saying it's like wannabe Skinwalker Ranch, like when it grows up, it'll be Skinwalker Ranch.
I think it's better because they don't have all that bad vibes at the Skinwalker Ranches. I don't hear about the dogs walking around.
That doesn't sound so good.
It doesn't. And you know what? That's underrated. Skinwalker is just misunderstood. That's it. They're not. That's the bad vibe. It's the vibe of being misunderstood.
That's like Batman, though. See, a blind frog, like it's in the dark. Does it need to see? Maybe it's like using it sonar.
Got some cool stuff there. That's what when I went on a tour, there were meteors, all little meteor bomblets spread all over the place, and that suggests there is probably a big meteor hit there, and there could be like a large meteor somewhere.
Oh, yeah, and sometimes when they burst in midair, they just shower the place with a bunch of little fragments.
Yeah, well, these are bomblets.
It comes in as a bullet and turns into a shotgun blast.
Well, you see some of them are around like this.
Kai said that there's better evidence and reports from Blind Frog than from Skinwalker.
I believe that too.
And
the name Blind Frog is very Pepe the Frog.
What?
This one.
Since you mentioned Batman, I want to point out that no one has ever seen Michael Boyd and Batman together in the same place at the same time.
They did, and then they had to shut down. They had to shut down the whole Batgirl movie because so many people saw. That was what happened, right? It was.
That's right.
I was just going to the bathroom, honest.
So, okay, it is the top. Well, it's 5:07. Mr. Bernie Conkin, would you like to do a LENR and energy?
You're looking pretty
update?
peppy right now. I can see all the coffee's flowing through you like the force.
I'm wearing an LENR hat, by the way.
Okay. Well, let me hand things over.